Hello and welcome to Video Academy for another programming video. This time we're going to take a look at the Python object-oriented programming, and it will be based on the book Math for Programmers, and we're going to discuss about defining classes, defining methods, special methods, operator overloading, which is a way to make any operator work the way you want it to work, then class methods, and then inheritance and abstract classes. So let's start. Starting with defining classes, probably it's better just to start writing instead of explaining what exactly is a class. Okay, a class is a way to construct your code in order to make it more understandable. So for example, this is a class rectangle, and all of the object of this class rectangle would be having similar functions and similar properties. So in this class rectangle we would have a constructor, which is a special method. That's why we do it with 2 underscores, and it is calling itself. The width and the height, I'm just using W and H because later I'm going to do this, and self.width equals the W, and self.height equals the H. In general, if you are taking a look in Python, you would see it like this: width here and height here. But if it is the first time you see a constructor, you would probably be not understanding exactly what is happening, so let's keep it this way for you. So we press Shift and Enter, and let's do what can we do with our rectangle, and we give it width and height, and something unfair has happened. Yet the word self here is mistaken, so we have it already. We can do this, and we see that somewhere in the main there is, in this address, an object. What we can do is we can ask for the width, and this is it. We can ask for the height. I just press tab twice and it shows up. Yeah, so far so good. We have a class and we have a constructor. Now we are going to continue with defining methods. And which method are we going to define about rectangle? It can be the area. So the area in general takes the object, the created one from the class. We take it here, but we don't take it here, as you see. For example, we don't have self, we don't write self, and this is how it is. This self is for the object. So just fixing my tabs. Okay, so return is the magic word, and we calculate width times height. This is generally how it is. So defining method, what can we do here is we can take this one and we can say, okay, rectangle dot area, and you see that the method exists. This is the address, bound method rectangle dot area of the main object, and if we want it calculated, it should be 12. This is how we calculated it. Of course, what else can we do? We can scale up a rectangle. We still need the self, and we need to know how much we scale it by. So factor, and it should be rectangle with factor times self.width and factor dot self height. This method here actually returns a new object of the same type, of the same class. Type and class shouldn't be mistaken. That's one of the reasons why Hungarian notation exists. If you know the story, write it in the comments or Google it. Okay, so let's see how it would happen. Let's say, what can we write here? We can say rectangle 3 times 4, scale 10, and it didn't know what to do. So we can say either assign it to an object, or we did some kind of mistake. Yeah, this one. This is the mistake here. So scale, and if we return a, we get this, but if we return a dot width, we should get the width here times 10. That's how it goes. And if we go here with height, just wondering, the height should be 40. So far so good. Next we go with special methods. Just having fun. Okay, what can we do in this class? We obviously have the width and the height, so it would be interesting to see this width and height. We already have this a, which is, I think, it's the scaled value here. So let's go and say, okay, I want to know the width and the height of the a. So there is a special method called dictionary actually. So we can call it with the 2 underscores called dunder, like Dunder Mifflin, if you know what this is. So yeah, this is how it goes, 30 and 40. And we can rescale it back, dot scale -5. I'm just wondering what will happen. Okay, I'm just a equals a scale -5, and then here we have some negatives, which is probably not okay, but still something. And let's return it like this. Okay, -5 again, just for the sake of having everything under control. So under control means not negative but positive. Okay, what else do we need? For example, we can compare rectangles. In this case, let's think about something. For example, we have rectangle with 3750 and height 5000 called B, and we can say, is A equal to B? The answer is false. Why is this? Because A dict actually looks like exactly like B dict. You can see this one, but the thing is that we haven't informed our class what exactly does it mean to be equal. So we need to put dunder eq here. So self other is quite okay. Then simply we say, okay, if self width equals other dot width, self and other are the 2 objects that we give, and self height equals other height, then return true, otherwise return false. We can write it like result equals false, and if this, then return true, else return false. Something like that, but instead of writing these 4 lines here, we can simply write this thing here. It's pretty much the same. Yes, so I'm just pressing Shift and Enter, and then trying A and B. A and B is still false, which is strange. That's probably because A and B were the old with the old class here. So let's see, B is this rectangle, And what about A? Okay, A is this one, so I'm going to rewrite B using these ones. And A and B now is true. See, that's great. The next thing that would be interesting for us in the special methods here would be actually saying what kind of rectangular is it, or whenever we call a rectangular, to see its representation. So this is another fancy method with donders that returns self dot, no, not self dot, but simply code. So something like rectangle, yes, rectangle, and self width by self dot height. Okay, we do like this, and then we can call A again. Probably this, no. Okay, let's see, would this return something? No. Then if we call it simply like this, then it should be yes. Or we can simply say, okay, print A. No, doesn't work. This is the string method, so we can say whenever we have the string, then return self dot like that. And now I haven't tested this, but should be something like this. Okay, no, still no. A to string, no, doesn't work like that. So something like this. Actually, the point is that A is still defined with the old one, where we do define A. Okay, we'll use B, and now everything should be happening. Yes, this is how it works. B is this one, or if we print B, it should be this one, or if we only call B, it should be this one. And these are our two methods, string and represent wrapper. And in this case, in order to save some problems, the one and the other are represented exactly the same. Okay, let's continue with the next one. And the next one is actually operator overloading. So operator overloading would allow us to do something like this: rectangle 1, 2 times 10. Of course, unsupported operand type for star, rectangle, and integer. Yeah, happens. This is exactly how it is. So what we should do, define another method here, and it's gonna be like this: self and factor, and it would be return self.scale factor. So pretty much this method here calls this method here. Okay, let's see how it will work. Yeah, 1 times 2 is a rectangle 10 by 20. What will happen if we go the other way around? For example, 10 times this one. 10 times this one is different than this one times 10. Thanks for listening so far. And the difference is like this one: armule self vector, and pretty much return self scale vector. Let's try it this way. Yeah, exactly the same. This is the difference between mu and r mu. I mean, it's different where the things are. Usually, if you want, in the general case, you implement both of them. It would make sense. Okay, next thing is class methods. So class methods are pretty much attached to the class itself. This is the class, and not to the object. The object is this one or this one, a, b. So what can we have? For example, we can have a rectangle dot square. What would it do? Pretty much it would look like this, square, and the first thing is would be not self but class, which is COS, and the other thing would be side, and we would be returning rectangle side side. And in order to know that it's a class method, we should have this beauty here. So how do we call this one? That's a good one. We can call it like this, rectangle dot square. See, we call the class and then square and then 5, and it's rectangle 5 by 5. And we can try to see whether rectangle 5 by 5 is equal to another object that looks like this. No, because 5 by 4 is not 5 by 5. And here we have this beauty here. We can say, okay, in the equalizer we can say print f comparing comparison between string self vs string other. And now when we press here, we should get this information, comparison between rectangle 5 by 5 versus rectangle 5 by 5. We can put a dot so it's more interesting here. Yes, this is how things are working. Okay. And the last part of the video is about inheritance and abstract classes. Or ABC, abstract base class. This is what ABC stands for. So let's define a class square that inherits from a rectangle. This is how it looks like, square like this, and then rectangle here. And we can define its init method or its constructor method. So it is self and s, and it will be returning super is this one actually. So super is rectangle dot init, and we take this s and we write it simply twice. So it's like size. I can write size so it's more understandable instead of just the letters. And we can also ask redo the wrapper class, and it would be self, so it would be return square self dot width. Yeah, makes sense. So this is our class square. Let's do it. For example, square 6, and it is square 6. And this class, you see the area is not defined, but what we can do is simply say, hey square, do we have the area method? We have it. How much is it? 6 times 6, 36. Great. So we can do the same with square 4. And we can also see that the square 4 is actually the same as rectangle with 4 by 4, because comparison between square 4 versus rectangle 4 by 4 is actually the same. True. I have implemented this one in the comparison. Okay, what can we do? What else can we do? I'll just copy and paste now a class called circle, just for the sake of saving your time seeing me talking and pasting. Let's put something like this, and I'll put also like a space between the methods. I'm not sure what exactly what was it, pip 8 or pep 9 is saying, but let's leave it this way. Looks okay to me, and it should end with a new line. Okay, so this is a circle. We have the constructor, we have the area, which is pi times radius, or radius squared. We have scale, we have equalizer comparison, we have representative, you have multiplication, and the scale, which is great. And now let's make sure that all our circle and rectangle are inheriting from something called abstract base method. So we have ABC, from ABC import ABC, comma, abstract method, tada. And now we have class shape. This is the basic. So circle is a shape, rectangular is a shape, anything is a shape, so to say. And the class shape, it actually imports from this one, abstract based class, not method. So if we have a shape that, if we have an object or a class that actually inherits from this one, it means that this one is an abstract. That it means that it cannot be initiated. We cannot simply have a shape. It should be something. This is our logic. It should be a circle, it should be a rectangular, it should be a square, it should be something. So what does it mean? We have the abstract method area, and we never would be able to create it because we don't know what is the area. The area of a circle is different than the area of the rectangle, so it stays like this. Then we have scale, and that's the same. Here we also have it. We don't know what are we scaling. Are we scaling a rectangle? Are we scaling a circle? But we can be having a comparison. So how are we going to make the comparison? It's going to be an easy one. We're going to compare the self and the whole dictionary versus the other and the whole dictionary. Talking about dictionaries, we had the dictionary somewhere here. Yeah, the width and the height. So yes, this is how we equalize, and we are going to implement also the multiplication and the right multiplication, which is going to be like copy paste, simply armul. Okay. Why did it like it? Self, comma, factor. It didn't like something. Def mu, return self scale. Oh yeah, of course. It's comma, what I was thinking there. Okay, and the other thing that we can do is pretty much make sure that our rectangle is the same as our circle, pretty much. I'll just copy it. It's like this, and we have rectangle that actually inherits from shape. That's how it is. And it actually says, okay, in this case I'll be having the area rewritten here, and I'll be having this one, and for all the methods that are inheriting from shape, they would be like this. Let's see. Yeah, rectangle is rewritten. I mean, the one from the up is rewritten. I'll just show you that we can compare rectangles. For example, 5, 5 with another one, 5, 6, and it is false. We can write print, so you can see where it is coming, comparing from shape ABC, and we are comparing self-linked with something else, and this is how it is. We have done the following. We have created the rectangle here from this class, but this class inherits from this shape, which actually inherits from the abstract base class, which has also this function here. So what are we gaining from the whole abstract method and inheritance? Well, in this case, if we have rectangle and circle, it is obvious that we can define these methods here, and they will be for all the classes of the shape. I hope this was understandable. And in order to finish with something nice, like for example true, this is it. Yes, comparing from. So in this video we have seen the following: pretty much a whole class called rectangle with a class method with its init, then area, then scale, equalizer for comparison, representing, and string, which are not the same thing. You can Google and you can write in the comments what's the difference between them, but in the general case you would most probably be okay to have them both defined looking like this, doing the same thing, unless you have a really good reason not to do it, and you can write this reason. I can guess of some that they exist. Okay, multiplication and right multiplication. In the general case they should be returning the same, unless you are multiplying matrices or other things like them. There was a specific mathematical rule that says that if you multiply A times B and B times A, it is the same, which I cannot recall now, but if this is, then that's great. If it's not, it's not. Then we calculated rectangle height. We defined some methods here like area, and I think area was the only method, and scale was the second one we defined. Then special methods like dictionary, which is actually really helpful. It pretty much tells us anything that we have there as properties. Here is the scale, the equalizer, and printing. Next we stopped on class methods. Class methods pretty much allowed us to use the whole class itself without going to the object. And at the end we finish with inheritance and abstract base classes, which actually bring us a lot. For example, in this case we can define a shape, and any class inheriting from the shape is actually implementing its methods. Here the abstract methods area and scale by itself, and if we want to compare something, then it doesn't have to implement the comparison because it is implemented in the abstract base class. Okay, so far so good. Thank you for staying with me so long. Enjoy the rest of your day and have fun. Bye.